I would like to ask you, who here writes a parallel software? Can you raise your hand, please? Good. Uh, I wrote interactive code viewer that allows you to see within a thread what functions can be executed and what functions cannot be executed from a given thread. Would you like to know how it works? Good, 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 good. So the product works like this. In a text editor, you choose a function that starts a thread. I calculate what can be executed and what cannot be, and only show you what can be executed and what cannot. So the solution to this has to have three properties. It has to be real time, because you don't want to wait for the results. It has to be ad hoc. You only need the results for the one function that you have selected, and it kind of needs to be quick. How do you do this? How do you calculate it? It's actually quite straightforward. It's a very simple static analysis. So you start with a function that the user has selected. You show that one, obviously. You go through all the call instruction that it has. And for each function that's referenced, you recurse into. So you show that function, and you go ahead until you stop under certain conditions. Now, if you choose Elixir, you will find out that you will have all these properties that you need. Because you have it ad hoc, you just start a thread that goes for the starting function. It sends a message to the browser to display the function. When you found another function, you just spawn another thread, and it will real time be shown to the browser, and it will be real time also in the sense that Elixir or Erlang has a file scheduler. So you will see all the results very quickly and as soon as they become available. Now, this works rather well in theory, but there is a catch. What if functions take other functions? Because if your functions take another function, this function may also be called. So you need to find out that this function can be called and show it to the user. Now, in order to calculate this, you don't only need to know what functions are being called directly, but you also need to know who calls you, who calls the function that you're processing. And for that, you need to know for every function there is, which other function it calls, so that you know who's calling you. And when you want to calculate this, you will find out that it gets rather slow. Why? Well, because suddenly you don't have to process only a subset of functions that you found, but you have to go through the whole program that you have. And then some things in Elixir tries to show up and slow your program down, because suddenly you have a lot of sequential code that needs to be executed. You have to go through the whole program. The scheduler that usually gives you real-time results suddenly gets in the way, because you're only interested when you have all the results. And the parallelism that's built into Elixir with spawning all the functions and making sure that they are only calculated once brings additional need for synchronization, which slows your execution down. Now, why is this? Why is this such a big problem? Well, because you started with a small problem with ad hoc execution, and as you worked on your problem, suddenly it changed. It's no longer ad hoc and real time. It's all at once, and it has to be pre-calculated in order to do something about it. So suddenly, a better solution would be to write it in a different language, where it will be faster and hence better for the user. So what's the conclusion of this? Well, when you're working on a problem and you're digging down, suddenly you may find a new requirement that changes your previous ones. And then you may need to rethink your whole solution. Oh, and about the product, if you want to know how it ended, you can buy me a beer at the after party. I will happily tell you that. Thank you.